Hi, my name is Dan Mallott, and this is the right tool for the right job, serving data from SQL Server. I am a principal for West Monroe. We are a business and technology consulting firm based out of Chicago, but with offices across the United States. If you're interested in learning a little bit more about West Monroe, what we do, or any job opportunities, please feel free to chat with me afterwards. I'll be happy to talk to you about everything that we do. All right. So the first thing I want to talk about today is that PASS is more than just Summit. I think that we've all seen this year that there's been extraordinary flexibility and adaptation from our various PASS pieces. So there's first of all, there's PASS Pro. So this is a paid membership to PASS. This is something new for this year. Unlocks exclusive training and networking. You get access to past summit recordings. So there's really some great value there. And in addition to supporting PASS as an organization and making sure that it's going to continue to be able to put on events like PASS Summit. PASS local groups, SQL Saturday. These are in your backyard, so normally provide some free training. The local user groups will meet once a month. Usually there will be one SQL Saturday per year. Some areas have two, so there will be a regular data focused one and a BI focused one as well. And then PASS Marathon, the virtual groups, volunteers. These are all things, so the marathon and virtual groups are available online throughout the year. Again, tend to be free events. Please check them out. It's a great way to enhance your career. And then for the volunteers, we always need them. Volunteers make PASS, the local groups, SQL Saturday, all of these things possible. Without volunteers, we wouldn't be able to put on the events that we do. Now, really important to me and to all the speakers, the session evaluation. So there's a link on the left-hand side navigation bar to rate this session. So in addition to the opportunity to win some fantastic prizes, as we always have at Summit, your feedback does help the speakers. For many of us, we look to having the feedback to tell us what we're doing well in our sessions, what we're not doing well, where we need to dive in deeper, where maybe we went a little too deep. And additionally, this year, personally, this virtual method of giving sessions has been different and challenging, and I would appreciate some feedback on that. You know, am I easy to hear? You know, how do demos and flipping between slides and things work? So please fill out the session evaluations. They are really important. All right, so this is me. I was originally a DBA. That's what I did coming right out of school. But since then, I've transitioned over into more software development. As my software development friends say, I got better. As my DBA friends say, well, you know, you went to the dark side. In general, my focus is on high performance data solutions. So how do we get data out of SQL Server or wherever we have it and serve it up to our consumers as fast as we can? And then in my spare time, I can be found on an ice rink as an ice hockey official. Obviously, that's looked a little bit different this year, but it's still been good to kind of get out of my house and skate around, even if it's with a mask on and all of the other things that we have to do. You can see my LinkedIn, my Twitter. Twitter is really probably the best place to get a hold of me. In addition, I will be posting a link to my GitHub where all of the demos are found after this. All right, so now that we have the standard stuff out of the way, let's talk about the session, right? So we'll do a quick introduction. Then I'm going to dive into how are the ways that we get data out of SQL Server when we're looking to serve it for applications, right? So we're really focused on applications, although we'll touch on some other things as well. And during that, we'll do some demos, look at some code, what this looks like. You know, if you're already a developer, you kind of know. But if you're a DBA and you want to understand the difference between what does this look like for traditional data access of traditional .NET methods, or entity framework, or something like Dapper that's much more lightweight. So we'll look at that so you can kind of see and understand when your developers moan and groan about certain methods, why. We'll look at use cases. So that's when are you going to use, what are the use cases we have? When are we going to use each of these methods? My opinion, I'm really interested to see what you guys have to say in the chat or in the question and answer afterwards. And then we'll finish up by touching a little bit on performance tuning and design. Definitely not the focus of this talk, but I did want to talk through some things, because when you're serving data for applications out of SQL Server, there's some things you want to think about, and some things that may be different from what we want to do in a perfect world. And then at the end, we'll have some time for questions. There will be a live Q&A, so please feel free to ask me anything that you have. Happy to answer everything, everything that I can in any event. So this was obviously the inspiration for my talk name, right? So Star Trek V, Scotty is, haranguing some junior officer about using the wrong tool, right? And so every time I see this, I get to thinking like, well, we have the concept of right and wrong tools in software engineering and data engineering as well, right? And so I wanted to put together a talk that talks through which of these are right and which of these are wrong, because different circumstances may call for different approaches. It's not all just use stored procedures, or, well, we'll just use an ORM, right? There are subtleties in there that we ought to know about and address so that we can have more honest conversations with each other. So how do we get data out? Well, I'm going to highlight three main ways for applications in any case. The first up, old reliable. These are our hard-coded SQL strings. So select, in this case, city ID, city name from application.cities, where city name equals Chicago. All right, so these are really easy and quick to write. Really low barrier to entry if you've got Management Studio or Azure Data Studio, or if you go for third-party tools, something like DataGrip or something like that. It's really easy to write SQL and get data. In addition, you have a really wide availability of tools to execute, so you're not just stuck with C# data classes, right? Or SQL OLADB connections, right? If you have an ODBC connection, a JDBC connection, you're going to be able to use SQL strings through that. And you get back only what's needed, right? If you have some of the other methods we'll talk about, you're sometimes a little bit limited, but this is the most customizable way of getting data out of SQL Server. On the downside, and this is the biggest one, hard-coded SQL strings are the biggest source of SQL injection vulnerabilities in the world. So these are where someone has taken a SQL string and they're just concatenating it together, and well, now you've created a SQL injection because you haven't done enough to sanitize the user input or put any controls around it, or anything like that. And so that's a huge drawback to using SQL strings. And when we look into the code here in a second, I'm going to talk through why. It violates code reuse principles, or can in any case. SQL strings, great. But they tend to get strewn about all over the place. Maybe in your application you have a file of SQL statements that you can reuse. But then you get into the next problem, which is this is difficult to manage at scale. So if I have a whole bunch of SQL statements and I change a table name or a column name, or I need to add a column, or add a filter. Now I've got to go through and look at each of these individually. And that gets to be challenging. That you miss things, right? And then your application doesn't work and you get angry calls from your customers. Nobody wants that. So, hard-coded SQL in applications, how to spot it. Let's switch over to Azure Data Studio. So here we have a good example of a hard-coded SQL query. So using wide world importers, our favorite sample database. Selecting everything from the city table that's sort of applicable. I'm leaving off the location because I don't want to look at a big binary string. Where city ID equals 6330. And wouldn't you know, Chicago. Great. All right. So now what does this look like in terms of application access, right? This is really easy, but what do the application developers have to do? So we'll flip over to Visual Studio Code. So I do have a full Visual Studio running in the background, which I'll kind of touch on in a second. But here is just, so we can focus in on the data access itself. You're going to see some very similar kind of setup at the top of this. Happy to talk through that afterwards. Just let's focus on the couple of regions that I have here. Okay, hard-coded SQL. Don't do this, obviously. So you'll notice, the first thing you'll notice for ADO is we've got 35 lines to make this work. So that's a lot of lines of code. People don't tend to be sensitive to that, but at least in modern .NET, we tend to prefer things that have fewer lines. All right, so we get into this. This is just getting city by ID, so we're going to wrap that same query we just saw in Azure Data Studio. And you can see I've defined the query. I'm using string interpolation on purpose. This is a really bad practice. Don't do this. City ID as ID, city name, okay, all of our columns. And you can see as I scroll over, I'm just interpolating in the city ID value that gets passed to us by the user. So what string interpolation does in .NET, if you aren't aware, it just takes the value and substitutes it into the string. So very similar to like a string.format call or something like that. All right, get a connection, SQL command, always have to open your connection. All of this await and async is just to make this work asynchronously. Create a reader, be a little smart about this. So if we don't have any rows, we're just gonna return null. And then I'm gonna read out one and return it. And so this is pretty straightforward, right? We're going to see this in action in a second. I'll go over Dapper and EF Core first. Note my one thing here is there could be a subtle bug if you're filtering on a column that's not unique. So this is something that I didn't want to make a big deal of all the code that you should put around this to make sure you're only getting a single result. So I just put that note in there. All right, what's this look like in Dapper? Okay, again, you can see there's some setup up above. 2 lines. This is better. But we still have the problem of we're just putting that city ID straight in and using interpolation. And that can run us into trouble as well. Okay, much simpler. I get a connection. I run the query off the connection. And we're going to see this a little bit later, that this is the thing that makes Dapper really powerful when it comes to doing this in ways that aren't a hard-coded string. Lastly, Entity Framework Core. So again, 2 lines, and the thing that Dapper and Entity Framework Core are doing for us that ADO doesn't out of the box is it's mapping to our result type automatically. So we don't have to write all that code. Again, you'll see I've used string interpolation on purpose, so that's not great. There is the ability to use a different type of command here that does do some sanitization of your inputs, but for the purposes of this and when people are going to be using this, this is probably how it's going to look, and you probably don't want to do this. So this is how we get this going in each of our different cases here, ADO, Dapper, and EF Core. Let's look at it in action. So I've got, I have an web API running in the background, so I'm going to be using what's called Postman to interrogate that, and we'll be able to see on the left side through that console window, we'll be able to see how long each request takes, and on the right side, we'll be able to see the request itself and what it responds with. So we're going to start with our city ID using ADO and raw SQL. In this case, we're using our 6330. So go ahead and click send. That sends the request. And we're just having a little slowdown. Great. Well, while we wait for that to come back, let's take a look at the way Dapper handles it. And again, we have a bit of a slowdown, so let's take a look at how EF Core handles this. And again, we have a bit of a slowdown, so let's see what's going on over here. Oh, looks okay. Well, we'll come back to that. Let's go ahead and cancel. These are already beyond cancel and cancel. And let's just try restarting our, yeah, looks like this guy didn't go very well here, so we'll restart him. All right, so let's try this again with ADO. There we go. So you can see we got the results. We'll do the same thing with Dapper. Again, we got the results, and you can see on the left side as we're hitting the different endpoints. Lastly, EF Core. And there we go. And now EF Core did something interesting that probably most developers don't know, is this actually wrapped what we gave it in a query itself. So this is something to keep an eye on. And this is also why you should always be logging your generated SQL from Entity Framework, because you discover cool nuggets like this. All right, so let's get back to the presentation. All right, the programmatic approach. So this would be otherwise known as using stored procedures. For most of us who have been DBAs or are DBAs or are charged with taking care of the database, using stored procedures is our preferred option. We really prefer this for a few reasons. They're quick to write individually. They are usually secure. Obviously, if you're doing some dynamic SQL and not taking care of your parameters, that's not great. There's a high amount of code reuse. Because like, hey, I need a stored procedure that gives me all the cities. Okay, well, here's the stored procedure that's been written and has been sitting in the database for 8 years. We also get a great deal of control over what the SQL itself looks like. So when we're dealing with hard-coded SQL, or as we'll talk about later, generated SQL, you don't have any control. You have all the control with the stored procedure because you've written it. Cons, again, sometimes this is difficult to manage at scale. So you might have a whole lot of stored procedures. They might be namespaced well, they might not be. Sometimes the predefined logic is restrictive. So maybe I don't need a stored procedure that gives me every column from the city table. Maybe I just need the city name. So then you have to think about, like, well, do I do a new stored procedure, or do I just say, well, only take that one column? But now you're transferring more data back and forth than you probably need to. And again, this is something to think about. Lastly, permissions can be a challenge, particularly if you are granting permissions on the object level the way you should. This is another managerial challenge, if you will. Still, far more preferred to use stored procedures than the hard-coded SQL we just saw. All right, your developers are going to try to convince you that using stored procedures is hard. They're not wrong, but they're not totally right either. So let's take a look at what this looks like so that we can, have some more honest conversations. All right. Firstly, in our old friend Azure Data Studio, we can run that, and what do you know? Only one city in our table named Chicago. It's only one. All right, so what does this look like in our various methods of getting data? So we'll go ahead and collapse this. All right, stored procedure, doing better. I think it's doing better. All right, so you'll notice this is pretty similar. The big change is that we have, instead of a large SQL query, we're just calling a single line. We are telling it it's a stored procedure. This SQL parameter up at the top, this provides us with SQL injection protection. The .NET framework has that built in, so it will scrub that city name for anything that's bad, right? And kind of scrub that out. Really pretty similar to the code that we had before for the hard-coded SQL. Just, again, we have this mapping logic, right? And so because we could be returning more than one city purposefully, we just loop through our results. All right, not bad, right? Really similar to the hard-coded SQL. There's really probably no reason to do this differently. All right, let's take a look at our friend Dapper. Yeah. All right, well, it's a slightly different way of handling the parameter, but really it's still a couple of lines. This is looking pretty good, isn't it? Like if I were using this as my data access management, this would be all right, right? And lastly, let's take a look at Entity Framework Core. So again, okay, so same kind of SQL parameters, so you can see that we're doing the same sort of parameter injection protection. And then the same from SQL Raw, but we're just running this in. Okay, that works. And so we'll see how that executes here in a second, but this looks pretty simple, right? So let's take a look at how it executes. All right. So we will search cities. We'll start with ADO and our stored procedure. We see our city name is Chicago. Go ahead and send that in. All right, that was great. Quick, 101 milliseconds. All right, we'll take a look at Dapper. Again, and you'll notice this was actually even faster, although, there's some reasons for that. And we'll take a look at Entity Framework Core. And again, we'll be able to see some more details about what Entity Framework is doing. Okay, well, and it actually figured out for us that was a stored procedure. And so it just executed it. Well, that's pretty good. And you can see it had the parameter. It sniffed out the size in this case because Chicago is 7 letters, so that's what we were searching for. So this was pretty easy, and it was all pretty quick. Although, the Entity Framework Core one was kind of slower. Let's see what happens if we run it again. Oh, there, it's faster, right? That's maybe an environmental thing, maybe a query compilation issue, who knows? All right, so that was pretty simple. So we're gonna come back over to PowerPoint, and our last option, tool-generated SQL, aka ORMs, although other things do this as well. And so we have things that look like what I have there, coming out of, in this case, Entity Framework Core. But you see these things in your extended events or in your query profiler, and it's, oh, yikes, this isn't good. What is this? Why would you write a query like this? So the pros of using tool-generated SQL, it's created automagically. So you write in whatever the fluently native syntax of your language is, and some magic in the background creates SQL for you. You don't have to write any SQL. It tends to be very secure. So where we've talked about the SQL injection protection that we had with our SQL parameter previously in our last example, you got to get all that as part of this. It's a thing that you don't have to think about too much as a developer, which can be good or bad. The toolset is highly accessible to developers, right? You are, and we'll kind of look at this, you're using very familiar syntax. Very often in C# in any case, you're using what's called LINQ or LINQ, language integrated query, which is a syntax for querying object graphs in C# or Visual Basic. And this is something that's very comfortable for developers. Cons, it produces what you see at the top, which in this case is very ugly SQL, but just fine in terms of optimization. But it can produce very, very non-optimized SQL as well. If you're interested, I have another talk later this week about getting ORMs to play nicely with your database. And we could talk more in depth about that non-optimized SQL problem and why it crops up. And then it can be really difficult to performance tune this sometimes. Particularly depending on your application access patterns, you might be pulling back, or you might have the ORM pulling back way more columns than you need to, and that creates an indexing problem, or just a amount of data passing back and forth. Maybe there's an I/O problem in there, and you just can't solve it because we're pulling back this giant wide table. And it just has to read it off the disk every time, or it has it's taking up all the space in memory, and there's no room for anything else, right? So how does this look implemented? I think you guys are probably gonna know some of this. Now, this isn't as scary as you think from a DBA perspective, and your developers, there's a reason why they prefer this, right? Okay. So nothing for us to do in Azure Data Studio, because the generated SQL that you have in Azure Data Studio or SQL Server Management Studio is very familiar to us, is that right-click select top 1,000 from a table. That is generated SQL. It just happens to be generated SQL that's not terrible. All right. ADO. You've probably guessed this one already. It doesn't do it. Darn. Yeah, if you're using ADO for your data access and you're doing all of this hard work to do all the mapping, that means you have to do the hard work to write SQL queries or stored procedures. It's not going to generate SQL for you. Dapper. Yeah, it doesn't do it out of the box either. So Dapper is what's known as a lightweight ORM. Dapper was developed by the creators of Stack Overflow and the Stack Exchange family of sites. And the idea was that they wanted to have something that was really, really lightweight, really, really high performance, so that they could have the fastest data serving that they could. They've since open sourced it. Anyone can use it. It's available on GitHub and through NuGet, and it's incredibly useful. It can do some very simple SQL generation, but it's only possible for CRUD, so get one, or create one, retrieve one, update one, delete one, and only with a separate package, so that's not in the Dapper package to begin with. So it's kind of it's there, you can use it. It's almost as high performance as the Dapper package itself, but out of the box, no SQL generation. Great, right? All right. Entity Framework Core, it's a one-liner. In this case, because we're just looking at, we're just giving me all of the states, right? If we had a parameter here, so for example, say we say, you know, now we're talking about a little filter here. Right, and so you see this is why developers like this, because it's a very quick, that's not correct. Yeah, very easy syntax to write. Very natural. Like, okay, state provinces where, just like SQL is for us, where you have select our columns from our tables, where this is a very easy way to write in .NET. It's very natural. Get rid of all this just so we don't end up modifying something we shouldn't. All right, so what does this look like in practice? Get our couple up, and then, so just as a reminder, we're going to see the full generated SQL over here, which will be kind of nice. All right. We only have one example this time, I'm sorry. All right, so we got back a whole lot of states over here, which is cool. Needed those. All right, all the way down, Oklahoma, Utah, Vermont. All right, 53 of them. I assume there's some provinces in there as well. You can see over on the left here, this is our generated SQL. S.state. Okay, so, and primarily, aside from the fact that we've aliased our table and we probably didn't need to, this is okay. Yeah, this isn't bad and executed pretty quickly. So, at least in this simple case, we haven't lost much by going with the generated SQL, and we wouldn't have gained much by putting this in a stored procedure either. So not as scary as you think. All right, let's talk through some use cases here, and then we'll kind of map our use cases to when you should use each of these. First use case, ad hoc. I just need data quickly. Whether you're sampling data for a sanity check or you need department requested some data, sometimes you just have to open Management Studio or Azure Data Studio and get some data quickly. The key things here, speed is the most important thing, and we're probably not repeating ourselves generally, right? Most IT professionals, if they have to do something a second time, they automate it, right? So we're not concerned with that here. This is a one-time request, or at least we think it is. CRUD. This is the simplest repeatable case we have, right? So CRUD stands for create, retrieve, update, and delete. Read the definitions here. Delete being the one that you want to be careful of and have some strategies around. This is the standard transactional work that the database does, right? And so for a large portion of your applications, you're going to be doing CRUD in some form. It may be heavier on creation, it may be heavier on retrieval, it may be heavier on updating. It's probably not going to be super heavy on delete no matter what, because we tend to like to bring in customer data and not let it go. Data search. This is something that's actually kind of hard. So again, we commonly see this in web apps. So think about like the product search in Amazon, or searching for a seat at a concert or something like this. From a user experience perspective, we expect a lot of flexibility here, and that's just something that we've come to expect. Google has spoiled us, right? We want to be able to enter in a single box and get back the data that is closely aligned to what we put in there. So this is usually going to involve multiple tables, multiple filter conditions, potentially multiple sort conditions, and when you're in this use case, there's going to be a temptation to do all the work in the database. From our perspective, from a DBA perspective, from a developer perspective, there's going to be temptation to do a lot of this work in the application, and that comes with some pluses and minuses. And then lastly, reporting considerations. So show me all the data. This is usually considered to be confined to applications like Power BI or Tableau or Excel, but you also see this in web applications and desktop applications. Some of them are reporting applications in disguise. So a couple of years ago, I worked on a project that was essentially a giant table of data that was filterable, sortable. You could drill in to individual ones. It was a reporting application. There was user interaction, but ultimately we were doing reporting. So that's something to think about. So what do we use? When? Help me. Or help me help you. So this is my slightly opinionated map. For those of you who know me, who've met me at previous summits or SQL Saturdays, I have opinions about this sort of thing. All right, so just gonna kind of talk through this, and then if you want to take a screenshot or whatever, or come back and look at this later, it's good. All right, hard-coded SQL, Adhoc. Sure, yes, absolutely. This is the use case. Please do it. CRUD, no, please, no. Data search, no. Oh, no. Reporting, you probably shouldn't, or no, but your tool might make you, right? You might have to define a data source that has a hard-coded SQL string in it. It's not great, but it happens. All right, stored procedure. For Adhoc, sure, but I don't know why you would do the extra work. CRUD, yes, absolutely. This is good at this, and particularly if you're using something like Dapper, absolutely use stored procedures for your CRUD. You can have all sorts of guardrail logic in your stored procedure that you don't have to put in your application. Yes, it is extra work, but it works well. Data search, yeah, but it's kind of hard. So I know there have been some, like Brent Ozar and others have talked through how you use dynamic SQL to build smart queries for a data search. This is definitely possible in a stored procedure. It's harder, right? It's going to take some more time. And then for reporting, yes, if your tool supports it, absolutely, please use stored procedures. All right. Tool-generated SQL. So this is our ORM SQL. Adhoc. Don't do that. Like, just don't. There's not a reason for this. It's like you take the overhead of building a stored procedure, and now all of a sudden you're building a whole application just to get some ad hoc data. That's probably not great. Okay, CRUD, why not? Right? Why not? If it's really simple, there's no reason not to. Now you can, the retrieval, if you're starting to get more complex, like, yeah, that's something to think about. But for a simple, like, get me a city, yeah, why not? Why are we writing that ourselves? Data search, you can, but you might kill your database. This is the place where it's really hard between stored procedures and tool-generated ORM SQL. There are some things you can do to help with the data search being not as much of a struggle for your database. So you can create a view that has the data that you need. on that project that I was referring to a couple of minutes ago, that's what we did. We built a view, and then we were able to really tune the access. We were able to get fantastic performance out of something that was bringing back like thousands of rows of data at a time. And then tool-generated SQL for reporting, you probably shouldn't, but you might have to. It's a reality. There's no getting around it. Some tools are going to generate that SQL for you. It is what it is. As I mentioned before, I will be taking questions afterwards, so please feel free, or if you want to throw them in the chat now, please feel free to throw some questions in. Disagree with me. I'd love to have a conversation about all of this. All right, kind of coming in towards the home stretch here. For all of these methods, we really need to think about query performance, because it can be a thing, right? Ultimately, nobody's really going to care how we get data out of our database as long as it's fast. So what are we going to aim at first? And so these are things to ask the development team. What tables or views does the application access frequently, right? So once you know that, you can start targeting your tuning efforts, right? Making sure that those tables have the right indexes. The views are properly constructed. You don't have like nested views, right? Ask them where the application seems to hang when accessing data. Like, is there a place that seems inordinately slow, right? Kind of, you saw earlier, right? I had an issue, and it turned out that it was the application, not my data access. But like, that could be the data access, right? It could just be the server is thrashing around, the SAN administrators calling you, like, what are they doing? Ask your development team if some data can be cached on the application side. So for example, if we have a list of states, provinces, those don't change very often. We can probably cache that on the application side. Those are queries we don't have to issue against our database. That's something we don't have to do. We don't have to clog up things with that. And then the last thing is the code performing the correct number of queries for the problem at hand? So ORMs in particular, but you can run yourself into this problem with whatever tool, tend to have a problem that we refer to as n+1. So that is, if I am looping through all of my orders and doing some processing on each of my orders, if I don't get my orders and my order lines up front, every time I process a new order in my loop, I have to go get the order lines. So now we have an n orders, right? Order lines, number of orders. We have a query for order lines for each of those orders, +1, the initial query that we did, right? But so that's the most common form it takes. It can take some other forms as well, right? We might have broken up our data access because we were building something iteratively, right? And it might be worth going back and seeing, hey, can we actually do this all in one query? Can we simplify this? Do we actually need to be pulling back all the data that we're pulling back? One of the things that .NET helps us with Link is deferred execution. But if we materialize our query, it's going to execute, right? So if we defer execution on a set of objects and we never use those sets of objects, well, the query never runs unless we've materialized it, which is the habit that many developers have gotten into. Well, now we're pulling back a bunch of data that we don't need. It's hurting our application performance because we're taking up more memory. We're spending CPU cycles to map the objects. And it hurts our database performance because we're adding an extra query. Like, why are we doing this? All right. What do we want to aim at second? So this is things to ask your own team, the database team. Is performance monitoring in place? Are you using extended events? You should be using extended events. Are all of your foreign keys indexed appropriately? This was one that still surprises me to this day, that we have, a client I was working with for the spring and summer, like none of the foreign keys were indexed. Like, this is so, it's such an easy way to improve your performance. Are all your candidate keys indexed appropriately? So it seems like most people run databases where we have surrogate keys, whether it's an integer or a GUID, holy wars aside, as our clustering key or our primary key for our table. But we don't index our candidate keys. And the reason this is important is because your candidate key is how we are going to uniquely look up an object if we don't have its ID, right? And so that's going to get a lot of action. And so if we index that up front, we're going to help ourselves. And then lastly, do you have some candidates for denormalization? And what I mean by that is, do we need to have a state table? I mean, maybe we do need to have a state table, but our address table doesn't need to have a foreign key to it. Just store the states on the address table. This is something that's relatively simple, and it lightens the load on the database without really adding any extra storage. And you can do this either physically or virtually via view, right? Particularly for things like Entity Framework, the fewer joins it has to figure out, the better you're going to see success. So there is one thing you need for all of those things. You actually need the queries themselves. Otherwise, how are you going to tune them? So there are many potential sources: extended events, the query plan cache if you don't suffer from cache eviction issues, logging from the application itself, you guys saw that, or SQL Server profile, or just use extended events. Have I mentioned that extended events are the way to go? Just in case Grant Fritchie's watching this session, use extended events. One thing we haven't talked about is optimize for ad hoc. Now, before I get into this slide too much, what am I talking about? Optimize for ad hoc. So when we look at our cached plans, so these are all the queries that have been running against the database since I started this session. I ran my free proc cache before this. Okay, they're all compiled, which is great. I'm only getting the things with city names. Maybe we should take a look and just get all the city ones. We'll get a few more, I think. Yeah, similar number. All right, proc, great. This is just our stored procedures. Some prepared. So we look at the text. This is these are coming from an SP execute, SP prepare. But then we have these ad hoc guys. So these are our, if you notice, they have something in common. There are all of our hard-coded SQL queries. And then if we get our, we go look at our, add in our state one. Well, yeah, here we go. Our state one that we got from Entity Framework core, it has ad hoc as well. So these are what are called ad hoc queries. Talk about this a little bit more. All right, so ad hoc and its friend force parameterization are incredibly broad and complicated topics that are worthy of full hour or 2 hour training sessions all of their own. However, if you are using a method of data access like Entity Framework Core that is causing plan cache pollution or plan cache bloat, or you notice that you have lots of queries whose only difference is a single parameter, or you have a lot of queries that were executed, you have a lot of plans in your plan cache that were executed one time, it's worth playing around with these settings. So optimize it seems to me that the consensus for optimize for ad hoc is that it should be on all the time. I don't necessarily agree with that. Forced parameterization, this would be if you have lots of very similar looking queries. In both of these cases, play around with them in your test environment. Everybody has a test environment, right? Do you also have dedicated production environments? Good, good. So play around with these settings, see if they help, right? Make sure that you've captured a production workload so that you can run that production workload, proper measurements, all those things. But this is something that can really help you out with your applications. Lastly, some design thoughts. Again, this is a topic that is worthy of its own full day session. Maybe I'll do one of those sometime. Split or combine tables where it makes sense. Sometimes, as far as your application is concerned, second normal form is going to be good enough, right? If you're just serving data up, it's cool. If you're adding data to the table, well, okay, now third normal form, you probably want to do that. But if you're just serving data out, the second normal form table or view, great. Speaking of views, use them to make access easier. I mentioned that the more joins you have to write, the more possibility there is that either you or your tool is going to mess it up. Views. Use our reusable database logic. Schemas are your friend. Don't just put everything in DBO. Now, the Microsoft team that put together Wide World Importers gave us a good example of how to separate things out by schema. You should consider where your data domains are and implement schemas appropriately. This also helps a lot with security. And then lastly, design for access patterns. Traditionally, with SQL Server relational databases in general, we've aimed for the perfect relational model and then said, okay, well, how do we optimize this so that we can actually get data out of it? NoSQL databases go at this from a different standpoint. Probably the biggest one is Cassandra, where it's you might have 40 tables that all look really similar but have slightly different sets of data because they want you to design for the access pattern, and they don't particularly care about duplicating data. Now, we care about duplicating data in the relational world, right? But think about your access pattern, right? Like I was mentioning before, index your candidate key. Have like, if you need to have a table that is partitioned, even if that's going to help you, then do that, right? So design for access patterns. We can do this too, and it can help. All right, with that, I want to thank you all for attending this session. As I mentioned, we will be having the live Q&A. I'd love to hear all of your questions, whether you want to do them live or in the chat. We'll talk through anything that you brought up from this talk. And I hope that you enjoy the rest of Past Summit. This is a strange year, but we're fortunate to still be able to come together, even if it's just virtually. And again, thank you. This is my Twitter, my email. Please feel free to reach out to me. I'm available if you want to talk about data access, application development, DBA war stories, or want to talk about what West Monroe is. I'd love to hear all about it from you. So again, thank you, and I will see you in the live Q&A.